Can you sketch a triangle if the lengths of its three sides are given? Let's try that out. How about we try making a triangle ABC of sides AB as 6 cm, BC as 7 cm and CA as 8 cm respectively. Let's assume AB to be the base. Its length is given to us as 6 cm. How do we draw BC and CA now? First, with point A as the center, we'll draw an arc of 8 cm and with point B as the center, draw an arc of 7 cm. Notice that the arcs intersect at this point. Can you guess which point this is? This point of intersection will be called point C. This length is AC and this length is BC. This gives us triangle ABC. You may measure the lengths using a scale and you will notice that all three lengths are as given to us in the question. Now we know that we can draw a triangle if we're given measurements of its three sides. What if we're given the measurements of 4 sides? Can we sketch a 4-sided closed figure using that? Let's try. Say you're given the 4 sides as 6 cm, 6 cm, 2 cm and 2 cm respectively. So it has 2 pairs of sides with equal lengths. Let's try sketching it. It may look like this. These 2 sides measure 6 cm and these 2 measure 2 cm. Is this the only way to create this shape? Let's draw AB as 6 cm first. We know the lengths of AD and BC. They're both 2 cm long. But this time, let me draw them at an angle like this. They're still 2 cm long, but we have just changed these two angles as compared to the first one. Now we join CD to get the closed figure. Are both these shapes the same? Are they congruent? Definitely not. In both cases, the opposite sides are parallel to each other, but the shapes are definitely not congruent. Is there any other closed shape we can create with these 4 sides? Let's take the base AB as 2 cm this time and from one end make a 2 cm segment like this. Let this be AD. The 2 sides remaining are 6 cm long. So we draw BC and DC of length 6 cm such that they meet at a point like this. Again, the shape is different. But what is a 4-sided closed figure called? Yes, you're right. It's called a quadrilateral. What can we understand from this exercise? This tells us that given 4 sides of a quadrilateral, we do not get a unique shape every time. If we are given 4 sides, there are numerous possible combinations of different quadrilaterals being formed. So how do we communicate the specific shape of a quadrilateral? We need one more dimension that will help us construct a unique quadrilateral. It can either be the length of the diagonal or the angle between the 2 consequent sides. I want to tell you one last interesting thing in this video. For all practical purposes, the sum of the lengths of any 3 sides of a quadrilateral would always be greater than the length of the 4th side. So if someone asks you to construct a quadrilateral with sides of lengths 2, 2, 5 and 10, you can easily say that it cannot be drawn. It's not possible to draw a quadrilateral with these dimensions. Why? Because 2 plus 2 plus 5 is 9 and it's not greater than 10. So we'll be learning to construct different types of quadrilaterals when different measurements are given. The measurements could be the lengths of the sides or the measures of the angles or maybe even the diagonals. See you in the next lesson.